Okay, so welcome to another mini chapter. In this one in particular, I intend to cover internal commands and some other built-ins as well. Here, the commands that I will talk about here, they will deal with input-output, file system. Some of the commands will be used with variables. Others, on the other hand, will be used in order to control script behavior and something that's a bit new, that's, I wouldn't say completely new, but definitely that I really haven't talked about until this point of time. There are commands that are used in job controls. What these are, in particular, you will see, I know the name sounds a bit strange and weird, but believe me, they are useful. All of them are pretty much hard-coded into Bash. Well, this can be good in terms of performance, but there are some other issues in terms of programming and in terms of access that are responsible, that are the cause of these commands, being created, let's put it so. I won't go into those issues. Whole books have been written on such subjects. Anyway, the very first group that I intend to cover of the internal commands will be I/O commands. So, these, well, we have already mentioned some of them, haven't we? We have used echo, right? We have used read. But what we have not used thus far is printf. And printf is such a universal way of outputting something onto the screen that you can find it in pretty much any programming language that is in existence today. For example, well, you certainly can find it in C and C++, and you can find it, I don't know, in Java, etc. Pretty much in whichever programming language you can think of, you can pretty much use printf. It's such a universal way of outputting something onto the screen. And what you learn here about printf, you will also be pretty much be able to apply this to, any other programming language. Some of them have different ways of outputting it onto the screen, but printf is still integrated and most people still tend to use printf. For example, C++ has cout, which is, I would say, generally hated, but I really don't want to spawn a debate here, so if you think that cout is better than printf and C++, I don't care. I really don't. I don't want to start a debate there. Anyway, coming back to the subject, let's take a look at our first example. In order for us to create it, let's go ahead and declare a rather unique variable, a variable with a rather unique value. Let's put it like that. Declare -r. I would like this to be read-only variable. I wouldn't like its value to be changed. So this will be typing in the value of pi. 314. Have it written here. The decimal place is 15926. Okay, I think this should be enough. No need for more. Hopefully you all recognize this value and you all know what pi is. If you don't know what pi is, well, use your favorite search engine and type "what is pi?" And yes, the internet will answer you. No big deal there. Just a math thing. People generally most countries tend to learn it like in elementary school, so I'm guessing that everybody knows. But the reason why I'm using it is because I can write pretty much as many decimal places as I want. This is only a few of them. They can extend for quite a while. I don't know, online you can find series of 20,000 decimal positions of pi or something like that. I don't know. But in any case, here's what I'm trying to. Here's my point. Printf, and printf will allow you to format the output on the screen. It will give you a greater degree of control as opposed to echo. If I type in, I don't know, second decimal of pi is, and here is how I would define how many decimal positions would I like to be printed out onto the screen. And in general, these decimal positions, numbers with these decimal positions like 0 point something or stuff like that. Those are usually referred to as floating point numbers. I do believe that I have mentioned them briefly before. If I type in percentage sign, 1 point, never mind the 1, like forget about it, it says 1 point something. You can say 1.3, and then F, and then this will, what we have, second, right? It's not the third, it's the second. So this, what we have written here, will now reflect itself onto a variable outside of these quotation marks. Fine. Right? Right, and there you go. It says second decimal of pi is 314, but this is such an ugly output. Let's go ahead and insert a new line. How would we insert a new line? Well, \n within the quotation marks will insert a new line character without any problems or without any extra arguments passed to the printf command itself. And there you go. It says second decimal of pi is 314. Let's say you would want some other decimal. Let's say you would want the fifth one. No problems. Just type in 5-1 and let's change this. Fifth. There we go. It says fifth decimal of pi is 3.14159. Pretty simple, right? No big deal. You format the output within the quotation marks here, and then it reflects onto variables here, or this variable in particular. So that is how we would be able to define like how many decimal places would be like to be printed out onto the screen. Okay, so I'm gonna cut it here, and then we will move on. Then I'll say a few more words about read, some of the things which we haven't actually done thus far.